Hi class, in this lecture we're going to continue in chapter 7 talking about quadratic functions by moving into section 7.5. Now this section for many of you might be a review from a previous maths course, but it's about using the quadratic formula to solve quadratic equations. Okay, so what is the quadratic formula? Well, suppose you have the solutions, or not suppose, the solutions of a quadratic equation. So it has to be in this form: ax squared plus bx plus c is equal to 0 always. All right, you can solve this by given by the quadratic formula. So the solutions to this: x is equal to negative b, so the coefficient in front of the x, plus minus. What this means is to do both, add and subtract, meaning this produces two solutions, plus minus the square root of b squared minus 4 times the a coefficient times the constant c, everything divided by 2a. All this is you plug the values right into the formula and it produces a solution for you and you solve. Okay, so just a warning, the fraction in the quadratic formula, notice that the negative b is actually part of the numerator. So this is correct, right? If you put the negative b out in front and just divide the 2a by this, it's incorrect. So this right here is the full solution. All right, so let's talk about solving by using the quadratic formula, something like this. So I want to solve 2x squared is equal to 10x minus 3. Okay, so the first thing you have to do is you have to write this in the form ax squared plus bx plus c. So I'm going to subtract the 10x over and add the 3. Now look, once I have it as 2x squared minus 10x plus 3, the value of a is 2. The value of b is negative 10. So whenever there's a negative, it comes with the number. The value of c is 3. So at this point, all you're going to have to do is take it and plug it into the equation. So it's negative b, so negative 10, plus or minus the square root of negative 10 squared, minus 4 times a times c, all over 2 times a. At this point, all you have to do is very, very simply just simplify the rest of it. Okay, so 10 squared is 100, minus 8 minus 24 here. So 100 minus 24 is 76. 2 times 2 gives me 4. And remember, as I said, the negative becomes positive. All right, when you have something like this, the 76, you want to try to, if there's any prime numbers in it, or do prime factorization, excuse me. So 76 breaks down into 4 times 19. Well, the square root of 4 is 2. So I'm just going to bring that outside the square root sign. So here we have two solutions. One is x is equal to negative 10 minus 2, because that's the minus part, the square root of 19. The other one is x is equal to 10 plus 2, the square root of 19 over 4. You could also factor out 2 in the numerator and also in the denominator, okay, as such, and that's perfectly fine. So like you see, when you factor out a 2, the 2 will cancel with the 4 and make that just a 2 as well. So that's okay too. Okay. So let's try this one. Let's find the approximate solutions to this one here. All right, well, you'll notice that it's 2.3x, and then in parentheses 1.4x minus 5.3 is equal to 6.9x minus 7.2. Well, first thing you're going to have to do is write this equation in this form. Ax squared plus bx plus c is equal to 0. So distribute the 2.3, okay, and you get the following. Now what you're going to have to do is you're going to have to subtract this over and add the 7.2 over. And this is what you have. You have 3.22x squared minus 19.09x plus 7.2 is equal to 0. Now, it is in that ax squared plus bx plus c form. So all you're going to have to do is substitute 3.22 in for a, negative 19.09 for b, and 7.2 for c into this quadratic formula. Once you get it here, all you're going to do is you're just going to use your calculator to help you solve it. Like if you plug negative 19 squared minus 4 times 3.22 times 7.2 in your calculator, you get this number. So all you have to do next is take the square root of it, and this is approximately equal to, now remember, we have two solutions. One is 19.09 minus 16.48 divided by 6.4, which will get us approximately 0.41, and another one here, excuse me, is 19.09 plus 16.48, which gets me 5.52 divided by 6.44. You can use your graphing calculator to verify this if you want, but those solutions do indeed work out. All right, let's solve this one here. What's confusing about this one here is the negative in front here. We haven't worked a problem like that. So the first thing you want to do actually is get rid of the negative. So multiply both sides of the equation by -1, so we can avoid having a negative denominator. So when you do, when you multiply everything by -1, it just flips the signs. So once you have it in this form, we're going to see that our A is 3, our B is -5, and C is -4. And you're just going to keep going with the quadratic formula. All right, so plugging in negative B, or negative B, which is -5, plus or minus -5 squared minus 4 times A times C, all over 2A. Now you'll notice here when you solve this, actually, it's a little weird. You get a negative under the square root sign. Okay, what that means is you have an imaginary number, right? Because you can't ever take the square root of a negative number. So all you're going to do is you're going to pull the negative sign out as the imaginary unit I. Okay, so that's how you're going to handle when you have a negative under the square root. All right, and you can verify this by plugging it into your calculator, and you can see that indeed that it does give you the imaginary unit. All right, let's do a modeling example. Okay, and we'll end on that. So annual consumption of bottled water in the United States has been increasing since 1990. Okay, so here are the years. It started, I have data starting in 2009, and this is gallons per person of consumption. So it was 27.6, and then by 2015, it was up to 36.5 gallons per person. All right, let's let f of t be the annual bottled water consumption, all right, in the billions of gallons at t years since that 2009. A possible equation of this function is f of t is equal to this right here, 0.163 t squared minus 2.446 t plus 36.43. Let's verify that the f models the data well. And then finally, let's predict when annual per person consumption will reach this 57 gallons. Okay, for some reason we want to predict that. All right, so if you plug this into your calculator, plot the points, and then draw the line through it, you will see that the model does indeed fit the data really well. Okay, so the next part we want to do is we want to predict when annual per person consumption will be 57 billion gallons. Okay, how are we going to do that? Well, we want the gallons to be 57, so we're going to substitute that in for f of t, and all we're going to have to do is solve for t here. All right, when you have this, first thing you're going to do, replace the f of t with 57. You're going to subtract it over. So we have 0 is equal to 0.163 t squared minus 2.446 t minus 20.57. At this point here, actually, all you're going to do is you're going to use the quadratic formula to solve this. So this is my b. Okay, so that's going to go into the b parts of the equation. This is my a, the coefficient in front of the square term, and this is my c, right, the constant term. If you plug this into your calculator, you're going to get the following. Square root that, you get the following here. And breaking it up, and just using your calculator to solve, you're going to see you're going to get two values. T is equal to negative 6.01. The other value is t is equal to 21.01. All right, so you can verify the results in your calculator. It works out. So the inputs here, negative 6.01 and 21.01, represent the years, because remember we started at the year 2000 here. Okay, so respectively. So we have the estimate of 1994 as the model. Breakdown, as little research would show that per person bottled water consumption in 1994 was much less than 57 gallons. So therefore, we predict it will be 2021. Okay, so a few years from now, when per person consumption of bottled water reaches this 57 gallons. Thanks, everybody.